Hello, everyone, and welcome to today's SANS webcast, Actionable IT OT Endpoint Protection to Detect, Contain, and Respond to Limit ICS Cyber Threats, sponsored by Verve Industrial Protection. My name is Carol, author of SANS, and I will be moderating today's webcast. Today's featured speaker is Ron Brash, Director of Cybersecurity Insights at Verve Industrial Protection. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Ron.
Hi there, everybody. So I'll just kick it off, as Carol said, on discussing actionable IT OT endpoint protection. Today's agenda is going to be a brief introduction on who I am and what I do. I want to discuss IT and OT convergence, endpoint security, particularly how we can make it safe in OT or critical infrastructure realms, how you can take action with endpoints to contain real threats and minimize impact in critical infrastructure, but also how do we shorten the gap between closed loop assessments and remediation, and we'll end it with an open question session. So who am I? So as Carol mentioned, I'm the Director of Cybersecurity Insights at Verve Industrial Protection. I was an ex-Dapino security developer. I'm a DPI fanatic for anything industrial, a bit of a packet jockey, security architect, embedded Linux and RTOS guy, and a researcher and technical lead. In the past 2 years, I was one of the main creators and developers of the ICS Detection Challenge, shown off at S4 in Miami for S4 18 and S4 19. I have a Bachelor in Technology that focused with a thesis that focused on the packet flow detection anomaly for xScale hardware, and also I have a Master's in Computer Science from Concordia University in Canada, with prototyping secure technology transition validations using SDN technology. So to set the tone, what I wanted to discuss was, what is convergence? So isolation is a blind alley. Nothing on the planet grows except by convergence. So to really understand what convergence is, we need to understand human tendencies and even those maybe, let's say, in nature. Everything converges, and nothing is truly in isolation, nor does it evolve alone. There's always codependencies, factors, drivers, and other participants pushing forward. And I'd like to say, and I believe this truly, is that business and industry and technology are no different. And that's also another reason why we're seeing convergence today. So talking convergence, I've kind of set the tone regarding it, but why does it matter today, and where does it look like we're going, regardless of, which side of the religious battle you're on or which side of the fence? So for technology and the drivers for ITO convergence, we need to look at the technological advancement. So previously, whether or not it was IT or OT, IT was probably the primary driver. But this was also true as the definitions of business and its motivations also progressed. Businesses are becoming global, if not already, but also vertically integrated and looking to garner improved efficiencies. Now, whether or not that happens at the inventory level for software or hardware, or just, improving the bottom line or efficiencies of a process, or even whether or not that comes from standardization or commoditization of technology, which is further enhanced by connectivity, it's all really about driving down costs, automation, and reducing technological diversity, but all in the name of increasing visibility, so gaining understanding of all sites and hardware or processes, sharing infrastructure, so reducing complexities, reducing costs overall ownership, and identifying and leveraging areas of improvement for various advantages. Now, whether that's increasing output, being more cost competitive globally, or competitive in general. So the picture looks great with what I would like to say rose-tinted glasses, and generally does look pretty good. But with all powerful motivations, it can also be quite negative. And if we don't manage those risks, then we can always misuse or have poor protections around these powerful tools. So for example, if we look at IT risks are fairly well understood, and they have been worked for quite some time. So everything's been networked. But OT is relatively new in the terms of time and also in global understanding. So, understanding the risks of that is quite negative. But as we move forward into a convergent environment, those risks and those impacts are going to become more readily prevalent or economically impactful. So as those environments become connected to networks and a variety of services, and as we know, air gapping is insufficient, we're seeing decreased separation of networks or equipment or sites, but also we're seeing combined IT and OT risks exacerbating the great potential for harm, whether or not that's economically for a state or for a large organization. It could result in safety-wise impacts, financial impacts, or even brand, but it could also be a larger issue, but again, it depends. So what we need to do is look at convergence from a balanced perspective. Now, to bring it all together, I'm going to exclude business here as the overlapping convergence, because that's one form of convergence. We're seeing IT and enterprise converging over OT at the business level. Now, if we're only looking at the IT side of things, information systems and OT technology, we're seeing a convergence at the controls and technology level. On the IT side, we can see management of a number of infrastructures, applications, business data, and even information such as user records or like Active Directory, for example. But on the OT side, we're going to see more operator and site level technology and activities. But if we look at the overlap, we're going to see data and its reporting in an area of convergence that we can generate a lot of insights around. So whether or not that's generating improvement or rendering visibility, data is going to be one of the main points of convergence. And it's not necessarily on the technology side exactly at that level. Now, we'll also see general processes as a form of convergence. So that might be, for example, matching user accesses. So if we have a user that's being maintained by an Active Directory tree, that's going to be the same in IT or OT in the same sense. Now, we might handle those edge cases differently, but the general process is going to remain the same if we acknowledge edge cases, of course. But holistically, we're going to see that convergence is really around the commoditization and standardization of hardware, software such as operating systems, sharing of networks and multi-proposed systems. So one server may host a variety of services or applications. We'll see hybrid clouds. So for example of that would be on-premise solutions being combined with cloud. So if we're, an enterprise maybe is using Azure, and in some cases are using a backup solution, but then also has a localized one, there's always going to be hybrid, and I think we're going to increasingly see that moving forward. But also, I would say we have convergence on cybersecurity as a whole too. Now, cybersecurity for both realms looks a little bit different, but the reality is that security for the organization as a whole is going to remain the same, and that's a convergent area. And that's more or less what we're going to talk about today. Now, whether or not one side or the other is right, and definitely a polarizing debate, convergence is coming regardless. And truthfully, it's really about, as I said, securing the organization as a whole, but also about reducing risks to the bottom line for those that are decision makers, those keeping their jobs or keeping jobs within the organization, maintaining production, and keeping everything in check overall. Now, I'd like to use an example that is a bit different than everyone else would. And when we're thinking about integration for IT and OT, everyone thinks either manufacturing or they think, Industry 4.0 or mining for some forward-thinking organizations. Aviation is one that we don't really think about. But every time I fly, and I fly regularly, we don't really think about it. But as a thought-provoking exercise, I would like to say that I don't think I've seen such a converged environment overall, whether that's between the business side of things or IT providing dedicated information and inputs to OT, or vice versa, the dependency on OT just to make sure things are running smoothly and safely. But aviation, so just hopefully you can hear me out on this. So from the moment you check in your luggage, or you make your reservation, or you're going in through the gate kiosk and getting to the plane safely to your destination, or getting your luggage back to you even, IT and OT seemingly work without hitches, despite transparent dependencies. You don't see them, but they're there. Now, when we think of OT, we usually think of, okay, we have our Purdue or ISA 99 styled model with all of our layers, but we forget that IT systems can clearly cause a dramatic effect on OT systems should they go down, even without causing a safety and reliability or productivity event. Now, I recognize that this might be a bit of an edge case, but if reservations are down at the gate or your luggage is already checked in, a passenger cannot get on board the plane at all, especially if the information cannot be verified. So that means that the plane can't take off without the manifest or without having your checked-in suitcase unloaded should you not board. And you'll say, what? That's true. So a little secret here from a travel hack. If you check in your luggage, the plane can't take off without you. So yes, that's a weird case of an IT OT system. But if I disrupt, just reservations alone or that suitcase process, I've actually compromised the OT systems without actually attacking them directly. So you can actually attack OT through IT systems. Now, again, I understand that that's a bit of an edge case, but it's an easy one for an attacker to pull off, with minimal effort. And again, there's other systems in aviation that are critical to the OT environment, where that the programmers used to program the plane, maintenance laptops, when the techs come aboard, other infrastructure around, managing software parts and data. All of these things can be used for managing maintenance cycles, conveyor belts within terminals, localized fuel stores, and even some airports connect directly to pipelines. So there's so much that we can look at from the OT side too, and all of these can be attacked. But also many of them leverage common ITS features such as embedded windows. They run common operating systems, and they use shared infrastructure such as networking. So I hope the next time you fly, you think, wow, that is really convergence at work. And I hope that they manage those combined risks well, because it is a big problem. So to kind of highlight some of those potential threats in convergent environments. Now here's a bit of a timeline here, and again, it's very vague, but across the board, you see that a lot of the attacks leverage Windows systems in general. And they're not necessarily specifically limited to, but those Windows systems, or even endpoints using common operating systems, are commonalities for infection points. Almost all of them are, they manage to find a foothold onto a common platform, whether that be through a Windows server or a privileged workstation such as the human-machine interface, User-Mine. That is almost ground zero for an attacker to execute activities on the floor or in critical environments. And so most attacks happen within those common platforms and in those common systems that are particularly convergent. And so this kind of outlines the true need of why we need to look at things not just at the network level but at the host level. How do we manage those sets of intrusion or sources of intrusion? So I'm sure you get it. So IT is well understood generally for risk and cyber threats, but OT and the impacts of it, of any incident, and the protections are far more intricate and delicate to manage. So even though there is convergence and there are paradigm differences between the worlds of IT and OT, we kind of need to take a couple points and weigh them with a grain of salt, but also put in perspective of the environments themselves. So OT was not initially designed for convergence. It wasn't necessarily designed for isolation, but it was isolated because if it wasn't broken, it wasn't fixed, and it did its job 24/7 for 20 odd years. But as we internetworked and as we, came across technology such as Ethernet or common networking and operating systems or new hardware, we realized that we can get 2 for 1 by putting all of these things on the same networks or on the same buses. And so we kind of wound up in convergence anyway, so without really wanting to get there, just because of convenience or whatever the business drivers might have been. Security is generally an afterthought, but concepts such as confidentiality of data is alien to the OT side of things. It's really about, can I rely on this data, and is its integrity valid such that I can ensure safe and consistent operations within my process? But also too, the versions of compliance are very, very different within IT and OT realms. And so process visibility at the end of the day largely trumps what we can do in terms of, for example, patching. We can't just reboot on a whim. We have to time it to, a shutdown of a refinery. So moving forwards, we can understand that how we do product development and how we deploy product, that lifetimes and how we do so are very different from each other in IT and OT. So we'd largely consider a 3-year cycle is that. OT can be 15 or 20 years, and I'm probably preaching to the choir, but I'd say Industry 4.0 is a far, far, far ways away, and it's going to look something more like Industry 2.5, 3.25, or 3.75, because there's always going to be legacy equipment needing to be transitioned or protected. And maybe I'll be a bit of a future-proof here, but IoT of today, or IIoT of today, is actually technically the same as a PLC of yesterday. We're still going to have to maintain it after end of life. So the risks of any OT will largely remain the same, whether or not technologies overall that, what we implement, but we still need to reduce those risks overall and adapt on them. But for risks, though, risks are largely dependent on the operational environment for OT. And this includes items of interest such as minimal downtime or scheduled downtime, or recertification of a lab every time a new patch comes out. So for example, pharmaceutical, it's going to cost X amount of dollars every time we want to do a patch. Now in high volume, low profit product, let's say aspirin, for example, or even pulp and paper, if we're looking at that, it's very, very not, it's not financially feasible, and it's probably never going to hit the radar of individuals that are probably already worked overall. So patching isn't necessarily going to come down, be used for risk management in traditional environments. Now, it doesn't say that's a challenge that can be solved. It's been solved. But we haven't even looked at even considering safety aspects for hazardous environments, and that is particularly tricky in OT environments. But there's also other challenges too regarding avoiding and minimizing potential disruptions due to safety, reliability, and productivity. And I'll probably refer to those as SRP as we go on. But we can't just reboot a system. We can't just re-image a misbehaving system. But instead, if a process can't be monitored, it could go unsafe. And so Bob or Jane, the operator, might just need to press the big red emergency shutdown button. So we need to really consider what are the risks and challenges when we're looking at doing security overall, but also how do we manage, for example, endpoint security. Now, if we're going to look at convergence, we kind of got to start with a common framework. Now, I know they're not 100% aligned, don't get me wrong, but we need to align somewhere. And one of those places is the NIST Common Security Framework, or the CSF wheel. And if we're going to apply the same cybersecurity rigor to OT systems, then it makes sense that we're going to use a similar system that the IT folk have been using for quite some time. And it might not be the best one, don't get me wrong, but it's among one of the most common. Now, a few systems, I would say, even in OT, and with respect to SRP, are going to be hard-pressed to not have elements of any of the standard operating procedures that do not fall into the 5 concepts, whether that's identifying, protecting, detecting, responding, recovering from a cybersecurity event. We can still align all of those assets to these kind of frameworks and requirements, at least so we can have a standardized terminology for conversation. So your real question is, can we secure OT systems? I'll hazard the guess and say yes, otherwise I wouldn't be here. It's really about balancing your risks to appetite and balancing risks to technologies that enable capabilities that are appropriate to OT. And there isn't, to be honest, there isn't really a single tool that standalone that protects OT. And I'll say this story again, I guess I'm too Canadian. It's not, you can't have one tool to fix all of the checkbox checkers. It's not the way it is. Now, unless your solution looks at and integrates into any number of solutions, and trust me, the market has a number of tools ranging from network security, monitoring solutions, whether that's anomaly-based or signature-based, that passively or actively looks for assets, or mere vulnerability management programs for patching IT solutions, or antivirus and malware platforms, or backup and configuration agents, or even, incident response integrations for centralized SOAR technologies, and maybe some even future technology I've never heard of or you've never heard of. But I believe that one technology, if you're just to deploy one security technology, whether it's on a wire or merely on a host, cannot actively protect IT and OT environments unless it integrates into a number of assets, including network devices, hosts, considers configuration, considers whitelisting of applications, can perform policy enforcement, and derives comprehensive reporting and more. And today, I do not believe that one technology does that, but I think a technology that does all of that, or most of that, and provides an efficiency akin to an 80-20 rule in terms of effort would be endpoint technology. And I'll refer to that as EP synonymously throughout the presentation. So endpoint technology being one of those technologies that I think that can really, provide a lot of value in terms of realistic threat handling is a key go-to here. But the real question for OT is how do we make it safe and effective, but also appropriate for our critical infrastructure? So endpoint security has a protection mechanism and a series of controls. Can it be done safely? Yes. And the reason why you would do so is, as I alluded to, is to prevent attackers from gaining access from common platforms, or at least trying to reduce the amount of access they have once they've gained a foothold. So if you have enough, for example, systems that may be unpatched, and they start excluding certain behaviors or attributes of a potential threat or threat indicators. And endpoint security if you're gathering all the right information, have the right tools on board, you should be able to get enough information to say, okay, I really need to investigate this. Whether or not that's a disgruntled user or a malicious entity on the outside, a behavior profile should still exist. And if you apply the NIST wheel to endpoint security, what do we do to make security work within the OT world? What are those requirements? But of course, I'm going to say this though. IT endpoint can do a lot of the things that we need to do inside of the OT world, but it may or may not be safe. I think there's caveats there. And so to make it safe, vendors and asset owners will need to do several things to make it work. Now, I'll say while it's a bit shameless, there's several challenges that exist for tools looking to breach into the OT environment. And therefore, a pure IT endpoint product might not be appropriate and safe for an OT environment. Now, if it's largely an IT infrastructure being classified as critical infrastructure and downtime or visibility isn't really required, that's one thing. But if, for example, an antivirus scan that would break a potential system is another, or a scan will cause a certain amount of changes to the host stability, well, then we need to look at it differently. So there's several points here, and just to summarize them, IT systems were largely designed to be coordinated centrally for efficiency purposes, but also do not acknowledge whether or not that they have compensating controls that truly need to be used regularly inside of OT environments. And that's particularly so where end-of-life or legacy systems exist or segmentation of networks is expected. Now, the reason why I'm mentioning compensating controls is if I have an end-of-life PLC or card inside of it, or several cards for that matter, and there's no way, and it's not cost feasible, or there's not even technologically feasible to upgrade it, then we have to work around those things. And that might be adding another firewall that needs to be managed, or just acknowledging that risk through an exception registrar. So we need to consider that. We also need to consider that because these IT systems are largely centralized, we'll have to breach our segmentation of networks in a different way. So that might mean that we have to have an out-of-band path that can bypass a lot of our controls. And in an ISA 99 style model, that we've already broken our model just to make these IT products work. So we have to look at things a little bit differently. But we also have to support requirements of a steady state or operating facility. So scanning can be risky. So for example, if we have low bandwidth over a radio link or a VPN, real-time connectivity, let's say to the cloud, is not possible to go that way in the near future. But of course, whether or not we can actually put agents or software on top of hosts is something actually might not even be possible at all together. So if that's a Windows CE or an embedded Windows machine, or is it running, some sort of lockdown version of Linux, or it doesn't even run any of those operating systems altogether, it's an RTOS, how do we put agents on those and how do we manage them? And we'll see that in many of the OT systems. So while that's not exhaustive, the concept to keep in mind for convergence is how do we make actionable convergence security safe and appropriate for OT. So at the end of the day, OT endpoint products must minimize risk safely through kind of these four main blocks and their feeds. I would use it as a checklist to ensure safety if I were a product owner. And that's what I would do. That's what I do as part of my job. So in fact, if I were neutral and an asset owner, I'd apply the same scrutiny that I would as a researcher by asking these questions in relation to these blocks. Is the product carefully designed and engineered for OT needs? Does it consider the consequences? So is it designed with industry experience that is specific to the environment that I'm going to be going after? So is it, if I run a refinery, do I have all of my constraints or my concerns as part of the product? So how they do patching, how they execute functionality. Does it consider consequences? And what sorts of expertise went into this product? If we just have a computer science background go into it, what is the history of the organization and founders? Do they come from industry and understand what our business is truly about? What are the features and integration? So proprietary only, I don't think will work very well in 2019. Maybe if that was a different business model from 10, 20 years ago. but it might not work so well today, particularly with convergence, whether that's data, operating systems, or applications. And are the technologies being used trusted and validated inside of the industry? So do they consider things such as overhead of hosts? So if I'm performing some sort of functionality, will it consume too many resources on the host or across the network? And can it be done safely? What about product testing and validation? Are there false positives? Will my users or my operators that actually use these products suffer from fatigue from too many alerts? And of course, there's always the concept of how do we handle or buy from end to end and do phase deployments and integrate continuous improvement and visibility. So those are all areas or checkboxes that I would have as an asset owner. And what are those controls within the product or process of development that can act as risk barriers? It's one thing to sell a product, another is to acknowledge and have controls that are tailored to OT. And of course, if I were an asset owner, helping me as the asset owner to be assured that that is a good product, and that is something that the industry and community should be proud of. Sorry, something happened here. So by using endpoints, we enable shared effectiveness by use cases to improve OT security. Now, what that means is by using endpoints inside of OT and IT, we can enable what I like to call shared effectiveness. And this is shared across use cases that can be common in both IT and OT. By doing this, you improve OT security, IT security, and the organization as a whole. So if we look at this chart, and it's an example, by the way, we can target known malware and vulnerabilities, and the handling of the threat changes. But the reality is that the use cases for the protection remain the same. There's nothing that says, wow, this is specific only to IT or it's OT specific. And again, I acknowledge that there is use cases that are going to be specific to one environment or the other. But for the topic of convergence or 80/20, we can knock a lot of low-hanging fruit out of the park for endpoint solutions, which is a win for every site owner, CISO, and security team. So for example, if I look at the known malware vulnerabilities, we can see that there's a series of patches or vulnerabilities that we can deal with technology. So whether or not it's upon detecting, responding to a traditional antivirus alert for a commodity malware that hasn't rewrapped or mutated, validating and applying whitelisting or proxies to alert when something malicious happens. How do we manage, unauthorized configuration alterations? Same with software installations or policy violations. Those are all things that happen in both IT and OT spheres. And again, I know their handling will change, but the reality is that we can look at applying endpoint security, maybe with customized workflows, but to provide the same sort of functionality with considerations to the risky environment. Now, for threats addressed when using endpoint security, just to summarize on the same use cases, you can use endpoint security to manage a number of different security threats, but also to be used in functional use cases. So whether or not that's looking at your known malware vulnerabilities on your y-axis, or looking across your x-axis, like prevent, detect, contain, or respond, and providing mitigations, you can handle a lot of those features. So whether or not that's managing unauthorized configuration alterations, or looking for malware, or looking at 0 days. Now, 0 days, again, is going to be a bit trickier here. But to further my point, you can use these several threats that are aligned with your usual, NIST 5 areas to target not just threats, but also to keep people honest, to improve asset ownership, information, validate processes, to ensure authorized configurations and ensure account accesses, and to provide data regarding a potential anomaly for investigation. So overall, endpoint security seems like a win that can't be taken lightly. It not only it beats what is performed merely at the wire or on a spanning port, and better yet, I would say endpoints augment other platforms such as passive solutions, but also products that offer threat services. So for case studies of using endpoint management to protect OT systems, I'd like to introduce my colleague and esteemed CEO, John Livingston, to hammer on a few of the use cases where our clients are clearly in convergent environments, and we help them navigate several obstacles successfully. On to you, John.
Sure. Thanks, Ron, and appreciate the time. So as I'm not sure everybody knows exactly who Verve is, so just a quick background. Our company does both services and software in the Convergence OT IT environment. And so we've got experience in seeing these endpoint solutions be deployed, not as a one proprietary solution, but bringing together all the required elements to make these things happen through our services organizations as well. And so what we want to do is to go through a couple of case studies to demonstrate how you can do similar type things of bringing true endpoint security and leveraging what's going on the IT side in the OT environments. The first is an example out of the pharmaceutical industry where this company was already in a converged environment. They had all their environments virtualized in a centralized data center. They had a lot of the key manufacturing applications were hosted in that data center, meaning there needed to be two-way connectivity between the manufacturing facilities and those data centers to enable those key processes to operate. The network infrastructure was integrated and managed centrally. And there was increasing desire to move to an industry, what's called in pharmaceutical manufacturing 4.0 capabilities, to not only allow software applications to work, but actually to allow closed loop information to come back in for everything from measurements to helping manufacturing workers identify particular pharmaceuticals by their serial numbers, et cetera. There was a recognition that obviously there's a significant threat here as a result of all of this, as evidenced by the Merck situation and others, and that detecting anomalies was not sufficient, or even signatures was not sufficient. There was a desire to have proactive management of the security. And so the idea was, how do we apply the same level of visibility, actionability, protection into our OT environment that we're seeing in the IT environment? And so, Ron, if you just quickly go to the next page here. And so what we did was we applied that NIST cybersecurity framework that Ron referred to earlier to be able to allow us to gain visibility to 100%. So basically to work through this wheel. So identify all of the assets to initiate protection, detection, response mechanisms, and also to integrate with recovery mechanisms. And so essentially put in place a series of endpoint management capabilities from, first of all, identifying visibility into all of their IT and OT assets by using the endpoints. So by using the endpoints to discover what else was in the system, we were able to gather 100% asset inventory without any hardware required. Build up configuration baselines, build up all the network connectivity and the rules regarding those things, and then using the endpoint management platform to be able to do OT safe vulnerability management without having to run scans of the network. So all the identification aspects, and then they were able to put in place an OT patch management system, which was what we call, was able to allow them to think centrally, but think globally, but act locally. So to be able to do the analysis around the patching and the vulnerability centrally, but then to enable the local plant to control an automated process of deploying those patches at the time which made sense for them after the right testing was done on those patches. Similar structure for configuration hardening of those endpoints. We help them deploy application whitelisting, which is very effective tool in the OT environment. In fact, oftentimes more effective than a pure AV tool because of the consistency. So we help them deploy that in a way that was safe for their OEM systems. and on around, detecting through detection of endpoint intrusion. So essentially a host intrusion detection in that OT environment, as well as configuration change management of those endpoints. And then finally around to the response, which is the ability to take actions on those endpoints because of as Ron mentioned earlier, so many of these threats are coming through many of the IT and Windows aspects. We're able to use those endpoint tools to actually take actions when when threats are detected, whether that be in the vulnerability sense of patching systems or changing configurations, or in a detection of a potential threat to be able to close ports or eliminate accounts, etc. And then finally, they were able to integrate their backup solution so that they could have full visibility of how up to date those backups were, and ensuring that they were able to actually respond in case of an incident and recover quickly. And so this is a case study of sort of applying these various endpoint solutions into a converged IT OT environment to increase the protection and the real-time aspect of being able to respond to a potential threat. The next case study I'll talk about briefly is a North American power company who was pursuing the CIS top 20 security controls. So in this case, as most NERC-CIP regulated entities are, they had a very segmented system between their IT and the OT side, but there was a firm commitment by the C-suite that all OT and IT systems would achieve the same standards of security controls in the CSC 20. And so it was a non-negotiable to figure out how do we converge our security mechanisms to achieve that same level of standard in OT as in IT, with a converged reporting and analysis for audits, and a multi-site, because of the multi-site highly segmented architecture, there was a need for a solution, an endpoint solution that could achieve the CSC 20, but in a segmented environment. So Ron, I'll have you go to the next page. And this is just a demonstration of and this is the last version of the CSC 20 chart. So some of the numbers have changed, but the basics are exactly the same. Essentially similar to the NIST cybersecurity framework, this client was able to apply these endpoint solutions to be able to do all of the inventorying of those systems, even in segmented environments. So being able to gather data at an endpoint, and it is feasible to do this across OEMs. So pretty much every OEM under the sun we had in these plants, to gather that endpoint information and push it up through segmented networks to be able to provide an inventory centrally, using those endpoints as essentially the sensors in the network. They had to provide full inventory of software, so not just what was visible in communications, but every piece of software on every system and the current versions, et cetera. And on around to the vulnerability assessments, being able to control admin privileges. So having full visibility into every endpoint and what the accounts were on those endpoints, what the password status was, configurations, et cetera. And so by applying endpoint security in this way, we were able to help them deliver both the compliance standard that they have, as well as an increased level of protection against threats, not to mention the ability to, from an operational point of view, to have much greater visibility into what was going on in their systems. And so in summary on these two different examples, very different network architectures, very different levels of IT OT technical convergence, both though with an aspiration to achieve that level of protection within their OT environment, similar to what they had in IT. And so there was a lot of need for sort of creative thinking about how to make these tools work in various types of networks, various types of assets. But the reality is it is doable, and it provides a level of protection and information that was not feasible to gain unless you move to an endpoint protection type scenario. So, Ron, let me hand it back over to you to talk a little bit more about the specifics of that solution.
Perfect. So, shameless plug again, the Verve solution. So, as of course, we've talked about endpoint security in 2 use cases. Endpoint product has to be targeted at OT with experience in the realm. It has to specifically be able to be managed and to be deployed in convergent environments with validated expertise. And so we kind of arrive at the Verve solution. Now, one of the things that we do, without getting into the nitty-gritty, is the approach of the endpoint or of Verve in general is to leverage agents and services through automation and automatic information collection that looks at all of the assets in both IT and OT environments. So that doesn't just look at your traditional hosts, whether that's your laptops, your servers, your virtual machines, but you also need to look at your firewalls, your switches, your routers, even applications, for example, application logs for Historian or RSLogix, whatever have you. But also going out and fetching information from PLCs and remote relays. And in future, of course, we should also always consider the cloud and hybrid cloud assets too, among the things that you should be adding endpoint protection to, or at least gathering data from. Now, to do this, once we gather all that information, we use that to generate profiles of assets to suggest and demonstrate risk mitigation with OT systems management, campaigning, and prioritization. So what that means is it allows us to build a map or some sort of cartography of all of the assets, applications, and systems that are within an organization. So it's one thing to know, let's say, for example, that box 123 is a Windows machine. But if you know that 5 different assets are talking to it, let's say, so for example, we have a human machine interface and it's talking to 5 PLCs or a DCS, and it has RSLogix installed, or it has some sort of programming software, and it has all of these other things, we can conclude that that asset might be a high-profile target, or at least one that we would consider a crown jewel within an organization. So that kind of information adds a lot of emphasis and information to be used by other products and services if you're trying to include your to strengthen your security portfolio of products. But also, how do you manage incidents internally? So if that high-profile target or it starts behaving abnormally, you can really escalate it as necessary. So that's one of the things that we use with automation, with gathering all the data. Now, to further that efficiency of the information obtained by those distributed agents, we then aggregate and massage all of that data through a unified reporting and tool handler that is designed primarily for action with minimal human effort. And so that would look like things like validation of patching or even of policy. It's one thing to push out a patch. It's another to push out a patch and validate that indeed it was installed and it was installed correctly. Many tools do not look for very simple things that have the checks and balances of it. And that's something that we do in addition to providing all of the automated data collection, but also in the way that we do our tool handling. So without kind of diving into it again anymore, but we need to consider that there's a ton of data there. And we've learned our lesson immensely, and there's a lot of data. And I would say that many that are just diving into that, if you're looking at wide-scale reporting, it's almost destructive testing. There's a lot of data. And with data requires understanding of just the data and all the multiple sources, but also how do you glue it together? And how do you manage the reporting in a way that a mere human mortal can understand it? Because at the end of the day, we do have bodies on the tools. We're not there with robots yet, or heaven forbid, artificial intelligence. But the way we do this is foundational to the way that your convergent environment security program has success. If you don't get the right data, or data is in general, and if it's not usable, then no tool is going to help you, specifically if it can't act on it. So what we've done with our product is to leverage a multitude of data sources, pretty much all across the board for all of our clients. You use a series of dashboards. You render actions that are based on what the end users will do. So whether that's applying a policy push or applying a patch or any sort of OT systems management or even far more functionality, you're so much more than an endpoint tool at that point. And so the agents that are on these endpoints can also be used as a node to fetch information actively and passively from your networks too. So not only do you need to apply new systems and apply new risks, for example, adding an inline tap or an inline firewall somewhere else or a proxy type service to fetch information from your plant floors, you can use the assets that already have connectivity and already exist within your network. So there's a major opportunity there for return on investment, but also leveraging what you have and what you already manage. Truly, at the end of the day, that is your foundational success. It's three elements. It's your data, your blue reporting, and that's really the magic. So just to circle back again, how endpoints really help with response is that it really gives you a comprehensive way of looking at a CSF-style threat model or at least incident handling model. So it gets you 100% hardware and software asset management. You're actually able to see what is on the host. You're actually able to make emphasis on things. So for example, I'll use this in the identify phase. If you are only looking at network traffic passively and you're in a steady state facility, and I'll use Ethernet IP as that example, if you do not see the plant come online or new tools come online or you're pulling those devices, you will not see that that is a particular device. So if the MAC, you'll see the MAC address point to X vendor, fine. You might be able to surmise that it's a 123 PLC, but you do not know the version of firmware it is unless you see certain packets either being sent from a programming station or from, for example, forward open. So that kind of information is only going to come from the endpoints themselves that know the project files, know the programming software, and have the configurations. You will not know, for example, some of the connectivity. You won't know the ARC tables, for example, on those endpoint hosts, or if there's a breach like a dual home NIC. You won't have all of the information to perform a vulnerability asset assessment that would be truly accurate, right? Largely vulnerability assessments, regardless of risk, they need extra information to improve their accuracy. Endpoint management as a source of truth can definitely exacerbate and improve the value of those assessments. And again, it balances out the protection mechanisms, whether or not that's patch management, whether or not that's configuration analysis, or ensuring what applications are on brand new hosts as they come online. So if a new virtual machine gets booted, automatically you get a push out of all of the software there to that host that is in compliance with your organization. Being able to detect and to garner data that can be used for instant response or triaging, whether or not an anomaly has taken place or not, or there's a hardware failure or software failure. You can manage, all of your incident response in a coordinated fashion. You can understand your containment mechanisms, and you can execute automated recovery procedures and processes. So endpoints can really provide value across the board. So what I'm trying to say is that it's really about closing the loop. So whether or not that's an assessment, a software-backed assessment, like such as using the tool in our reporting, it allows you to establish a baseline so you can detect and evaluate. It allows you to build your patching matrix, for example, your configuration changes, to understanding what your remediations and your fixes will be, and overall just improving the monitoring status and visibility that you have so you can perform automation. So in one of our customers here, we actually saw a roughly 100% increase across the board on NIST CSF controls. And again, I understand that the CSF may not be appropriate for all environments, but it is a way to have a discussion that uses a common vocabulary. It would be the same as, why two individuals that want to talk computer science or talk IT or talk English for that matter, study or speak the same thing. The NIST CSF or any standard is a way for multiple groups to have a conversation that they all understand. It'd be like talking Greek to an English person. So what we can do with our tool is allows organizations to say, here's where we have improved or here's where we need to improve. And so we can do that across distributed facilities to understand what the impacts are, or where their improvements are and where they're getting value to. So it allows you to have educated conversations even within your organization and show this is where we've done well today. So kind of to close the loop, that was kind of my tour of IT OT convergence and how endpoint protections are safe within OT environments. I believe, and I think that many of you maybe are convinced now, hopefully, that this is an absolutely required tool for OT security. It's not a should anymore. Just putting a box on the wire and listening passively, while it still has value, isn't necessarily going to get you the level of detection or level of protection that you're wishing for. And many of OT's unique, let's say, challenges or risks can be solved and have been solved while increasing security within your organization. And so I'll kind of open the floor for any questions.
All right, thanks for that great presentation. We have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. Our first question is the endpoint data presented in real time?
John, would you like to answer that one?
Yes, well, so two different settings can be had. So all the log data is presented in real time. The software and vulnerability information is presented in as frequent a time as you want it. Typically, we schedule that for about every 15 minutes, but can be done in much more frequent periods than that. So hopefully that answers the question.
All right, thank you. How do you get visibility into the inventory?
So, and Ron, maybe I'll answer a couple of these. So the way we do that is by leveraging the Verve agent. So Verve deploys our agent on all of the Windows, well, doesn't have to be all of, but essentially at least one Windows, Unix, Linux type box in a subnet. And that agent acts as essentially a sensor in understanding what else is in that environment. So that starts the inventory process. That then gathers device type, et cetera. We then, depending on the device, we've been around for about 25 years, and we've built a whole range of communication vehicles that we use to communicate with those OT type embedded devices in the protocols in which they are used to communicating. And from that, we gather back firmware inventory for our vulnerability information. And then typically we'll then deploy agents into the rest of the Windows, Unix, Linux type environments to further deepen our perspective of the inventory.
All right, thank you. Our next question is, we have a project to discover all software on the network. I asked IT if discovering software on endpoints was possible, and they said no. How is this possible? It sounds too good to be true.
It's possible in a couple of different ways, actually. So, as I mentioned, the way we discover the software, and think about three types of devices for a moment. Think about those with an OS type environment, those with like a switch or a networking device that has a switch or networking type firmware, and then those that are, I'll call it OT embedded type devices like a PLC. So starting with the first, we use our Verve agent to do that. That agent gathers somewhere around 1,500 different pieces of information off of that asset. One of the screenshots we showed there was an inventory picture, but it gathers every piece of software on that system, the date it was installed, the last date it was used, the versions, patch status, etc. So that's how we gathered the software inventory on those. On the networking gear, we communicate that through a service. So we gather those, the firmware, by communicating with those devices through SSH, SNMP, a variety of forms. And then on the OT devices, as I mentioned, we gather that by communicating in those proprietary protocols that those devices speak. And we gather back the firmware, which is essentially the software on those devices. So yes, it's very doable. Happy to show much more details about how the kind of data that we get.
All right, thank you. Our next question asks, so this uses a network capture to gain info about the RTUs?
I'm sorry, the question was, does it use network capture to gather data about RTUs? Is that the question?
Yes. Yes.
No, we do not use packet capture. The approach that we use is not picking up packets off the wire. Our approach is to essentially to communicate with the endpoints themselves and to manage the endpoints as endpoints. In the RTU setting, we will communicate with that RTU and gather back the information from that RTU directly. So we are not relying on the packets to interpret what's on the wire. We are gathering the data, quote unquote, from the source rather than off the wire, which means that we don't need to put in taps and span ports and other types of infrastructure into the network to do this.
Great, thank you. Do you think in the near future we'll have IT networks extensive featured analog Windows EDRs for ICS Windows endpoints?
Sorry, I'm having a little tough time hearing you. Could you just repeat the question?
Sure, and look in your questions window. I'll assign it to you there so you can see that as well. Do you think in the near future, we'll have IT networks extensive featured analog Windows EDRs for ICS Windows endpoints?
Yeah, I would think so. I think it depends on I don't think we'll have it for all the legacy equipment. If what you're asking is, will you be able to do all the exact same things on an embedded, Slick 5 PLC that you do on a Windows device? Probably not. But I think if you look 3 to 5 years from now, I think the newer devices are going to have a heck of a lot more capabilities for management than the legacy. The reality is you'll always have to deal with the legacy, though, most likely.
All right, thank you. From a supply chain perspective, any thoughts on what we can do to get better visibility into IoT devices prior to acquisition and subsequent deployment?
I'll handle that one. John, you want to have the first crack at it, and then I'll join in?
No, go ahead.
Okay. So one of the issues with IoT, and this comes from several aspects. So if they're running Linux, and this goes for any kind of devices running Linux in general, most companies do not manufacture them themselves 100%. They actually usually come from reference board designs, whether or not it's from China or some third party. And so they're using what's called a board support package, and there's inherent vulnerabilities throughout, from building of them to deploying them into the sale within the product owner itself. So that would be the creator. And if I were an asset owner, there's several challenges there. So one is I don't necessarily know what's inside of that system. So I have a couple options there. Definitely, if you're going to do a large scale acquisition of IoT for critical systems, you're definitely going to want to include some sort of audit type purposes. So whether or not that's making sure that they have vulnerability management as part of the processes, so that's one of your requirements as part of your procurement process, and you could validate that again with contractual purposes. But you also want to make sure that you have a way to analyze the software inside of it, and then again, that's very tricky because largely nowadays, if you're looking at containers or binaries such as statically compiled Go, they have dependencies buried inside of them that you don't necessarily know. So let's say, for example, I'm looking at ABC application. It might have a version of or some libraries that, for example, that provide TLS or SSL functionality buried inside of them. And you'll never know because that vendor has never posted out what their actual dependencies are. So you won't know what their vulnerabilities are unless something happens. So there's a bunch of, there's a lack of transparency and opaqueness. You could probably do a bunch of features such as signature matching and so on to validate, some of the things in the upgrades or in the firmware pushes. Those are all going to be things that you're going to have a very, very hard time understanding for IoT risk. Now, over time, I think what we'll see is more researchers will be pushing updates, but I think we might also see common platforms emerging. So vendors will try to be as close to, let's say, for example, vanilla software such as a Linux kernel or vanilla programming languages and frameworks. And so you'll kind of see a convergence of speed later on as a way to manage some of those cyber threats or vulnerabilities. But in the meantime, while we have this fragmentation of application, software, and vulnerabilities, you own this at the end of the day, regardless. Even if there's letters of risk transference, because it might be you that wears the stain on your shirt when you spill your coffee at the end of the day. So what I like to use for an analogy of this, and I used it recently, was that if we're looking at an IoT device, or let's say an IP camera, we know, or you should be aware as a purchaser, that you are inheriting all of the risk of owning this device. The same is true when you buy, let's say, a front-wheel drive car, or a car that might not be the best to drive in the snow up here in the Great White North of Canada. So what you're going to do is you're going to apply a specific set of controls to try and protect it. So those controls in the front-wheel drive car scenario is I'm going to put a set of winter tires on it that have studs, right? So that will decrease, or at least reduce, some of the risk that I have of going off the road in icy conditions. So I have traction. My other options are to drive it in the snow and not care and crash it into a tree, which would be the kin of not protecting it. Or I keep it in the garage and I protect it that way. So that would be the kin of putting it in a firewall zoned area where it cannot do any harm. Or I limit my exposure to specific, streets, for example. So if I know I'm on a bus route, I will drive my car only on that road because I know that that road is salted versus the side roads that are not. You need, for IoT and security management, you also need to consider your segmentation, your management of it, and you definitely will want to monitor where you do not have visibility for anomaly. That is about the best protections that you can currently have at this point until we better understand IoT devices or IoT devices. But consider them kind of black boxes that would be akin to a PLC of yesterday.
All right, well, that's all the time we have for today. Thank you so much, Ron and John, for your great presentation, and to Verve Industrial Protection for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.